On July 1st, 2025, a telescope in Chile quietly logged a faint speck of moving light that nobody on Earth had ever seen before. The object was first labeled with the plain designation CU 2025 N1, but within days, astronomers realized they were looking at something far rarer than an ordinary comet. Its path through the sky wasn't curving the way objects that belong to our solar system curve. It was moving in a straight, open, hyperbolic line, the unmistakable signature of something that didn't form here at all and was never going to stay. That object is now known as 3I Atlas, and it is only the third interstellar visitor ever confirmed passing through our solar system, following Oumuamua in 2017 and Borisov in 2019. And over the months since that first faint detection, some of the most powerful telescopes humanity has ever built, including the James Webb Space Telescope, have turned to watch it, giving us our clearest look yet at a genuine visitor from another star system. Let's start with what actually makes something interstellar in the first place, because that distinction matters enormously. Every comet and asteroid native to our solar system follows an elliptical orbit, a closed loop bound by the sun's gravity, meaning it swings in close, loops back out, and eventually returns again on a predictable schedule, sometimes decades later, sometimes thousands of years later. But it always comes back. 3I Atlas doesn't do that. Its trajectory is hyperbolic, moving so fast and on such an open path that the sun's gravity can bend its course but can never actually capture it into orbit. It came from somewhere out among the stars. It's passing through our solar system just once, and once it leaves, it will never return, drifting back out into interstellar space for good. That's precisely why astronomers dropped everything to study it so intensely the moment its interstellar nature was confirmed. A window like this doesn't come around often, and once it closes, there's no second chance. Almost immediately after discovery, an entire fleet of telescopes and spacecraft began tracking the object, essentially assembling humanity's most comprehensive real-time study of an interstellar visitor to date. NASA's Hubble Space Telescope captured an early image on July 21, 2025, when 3I Atlas was still about 277 million miles from Earth, revealing a teardrop-shaped cocoon of dust streaming off the object's solid, icy core, exactly the kind of glowing coma you'd expect to see forming around an active comet as sunlight begins warming its surface. Based on those early Hubble images, astronomers estimated the upper limit on the object's diameter at around 3.5 miles, though they were careful to note the true size could be dramatically smaller, possibly as little as 1,400 feet across, since a comet's glowing dust cloud can make the actual solid nucleus hiding at its center very difficult to measure precisely from a distance. Then, on August 6, 2025, the James Webb Space Telescope took its turn, using its near-infrared spectrograph instrument to study the object in a wavelength of light our own eyes can't see. But that reveals something Hubble's visible light images simply can't, the precise chemical fingerprint of exactly what the comet is made of. Around that same window, NASA's newer SphereX observatory also gathered roughly a week of data on the object, from August 7th through the 15th, while the Gemini South Telescope in Chile captured images in late August, showing the comet growing more active, its tail visibly stretching longer as it moved closer to the sun's warmth. Even spacecraft never designed with comet hunting in mind got pulled into the effort. NASA's Mars Reconnaissance Orbiter photographed 3I Atlas on October 2nd, as the comet swept past the red planet's neighborhood. And just over a month later, on November 6th, the European Space Agency's JUICE spacecraft, originally launched to study Jupiter's icy moons, used its Janus science camera to capture its own view of the comet's structure. By the time all of this data started coming together, 3I Atlas had become one of the most thoroughly observed objects in the history of solar system astronomy, tracked simultaneously by NASA's Hubble, Webb, TESS, SWIFT, SphereX, the Perseverance rover on Mars, the Europa Clipper, the Lucy and Psyche missions, the Parker Solar Probe, and several other spacecraft besides, an extraordinary, almost improvised planetary defense-style effort mobilized specifically because nobody knew exactly when the next interstellar visitor would come along, or whether we'd get nearly this good a look at it. The most genuinely important science, though, came after the comet swept past its closest approach to the sun, called perihelion, in late October 2025, and Webb got a second, deeper look at it in December. On December 15th and 16th, and again on December 27th, Webb pointed its mid-infrared instrument, known as MIRI, at 3I Atlas, while it sat between roughly 204 and 236 million miles from the sun, specifically hunting for the chemical signatures that only become visible once a comet has been thoroughly baked by solar heat and is actively venting gas from its surface. What Webb found genuinely surprised the research team studying it. The comet's glowing coma turned out to be extraordinarily rich in carbon dioxide, richer, in fact, than almost any comet ever measured from within our own solar system alongside clear detections of water ice, water vapor, carbon monoxide, an unusual sulfur-bearing compound called carbonyl sulfide, methane, and even trace amounts of nickel. That specific chemical mixture matters enormously because it strongly suggests 3I Atlas didn't form anywhere near our own sun. It appears to have condensed and frozen together in a completely different, much colder region of the galaxy, under chemical conditions distinct enough from our own solar system's formation that scientists studying Webb's data have said the comet is genuinely unlike anything else we've directly measured up close. And then there's the age of the thing, which is honestly the detail most people find hardest to wrap their heads around. Our own solar system is about 4.5 billion years old. Based on models of where interstellar objects like this are likely to originate and how long they typically take to drift across the vast distances between star systems before happening to cross paths with our own sun, astronomers studying 3I Atlas have suggested it could be roughly twice that old, potentially formed around a much older star long before our own sun even ignited, then ejected from its home system by some gravitational disturbance, perhaps a close encounter with another star or planet, and left drifting silently through interstellar space for possibly billions of years before finally, almost by pure chance, crossing paths with our own solar system on the exact trajectory that let Atlas's survey telescope in Chile spot it on that 1st of July. Combine that ancient origin with the follow-up measurements astronomers managed after perihelion, and the picture becomes even more precise. A separate analysis of Hubble's post-perihelion observations, gathered between December 2025 and January 2026, allowed researchers to successfully pin down the solid nucleus buried at the center of all that glowing dust and gas, inferring an effective diameter of roughly 2.6 kilometers, give or take about 400 meters, based on typical assumptions about how reflective a comet's surface tends to be. That's a genuinely large nucleus for an interstellar object, roughly 1.5 miles across, a solid core of ancient ice and rock that has survived an unimaginably long journey through the emptiness between stars, only to spend a few brief months lit up and actively venting gas as it swings past our own sun for the first and only time. Now, no honest account of 3I's Atlas would be complete without addressing the elephant in the room, because this comet became genuinely famous for reasons that go well beyond its chemistry. A Harvard astrophysicist named Avi Loeb, the longest-serving chair in the history of Harvard's astronomy department and someone who has published hundreds of peer-reviewed papers over a long career, began publicly arguing, through a lengthy series of essays, that some of 3I Atlas's behavior looked strange enough to seriously consider the possibility that it wasn't a natural comet at all, but potentially an alien artifact, at one point describing it as a possible extraterrestrial mothership. Loeb pointed to a handful of specific observations he considered anomalous, including the object's unusually precise alignment as it passed close to several planets, its glow appearing to come from in front of the object rather than trailing behind it the way a typical comet's tail does, and a measurable non-gravitational acceleration in its trajectory, meaning something beyond the sun's gravity alone appeared to be nudging its path very slightly. In October, Loeb went as far as publicly suggesting people should take vacations before the end of the month, a comment that sent conspiracy-minded corners of the internet into overdrive, with some online commentators claiming to have detected coded signals or deliberate communication patterns hidden in the object's light. The response from the rest of the professional astronomy community was fast and largely unified. Researchers including Chris Lintott at Oxford and Daryl Seligman at Michigan State University publicly dismissed the alien technology framing, with one detailed technical rebuttal, published by an astronomer running a blog called AstroWrite, going through Loeb's list of supposed anomalies one at a time, and showing how each one fits comfortably within known ordinary comet physics. Once you account for measurement, uncertainty, and the genuinely unusual but entirely natural conditions this particular object appears to have formed under. The non-gravitational acceleration Loeb highlighted, for instance, is a well-understood phenomenon in ordinary comets too, caused simply by gas jetting unevenly off a rotating, heated nucleus, acting like a tiny lopsided rocket thruster. Exactly the kind of behavior astronomers have documented in dozens of completely mundane comets native to our own solar system for decades. NASA and the broader astronomical community have consistently classified 3I Atlas as a natural comet, and even reporting on the Pentagon's own dedicated office for investigating unidentified anomalous phenomena found no evidence supporting an artificial origin either. It's worth being fair to Loeb here, since even his own writing at times acknowledges that a natural interstellar comet remains the most likely explanation, before spending considerably more time exploring the more sensational alternative, a pattern that's drawn criticism even from colleagues who otherwise respect his willingness to publicly entertain unconventional ideas. The honest, evidence-based summary is straightforward. The overwhelming consensus among the researchers who actually specialize in comets and interstellar objects is that 3I Atlas looks, behaves, and chemically resembles a comet in essentially every measurable way, just an extraordinarily old and scientifically valuable one. So where does that leave things now, in the middle of 2026? 3I Atlas has already made its closest pass by the Sun, swept back out past the orbit of Mars, and is now steadily heading back toward interstellar space. Exactly the one-time visit its hyperbolic trajectory always guaranteed it would be. Once it fades beyond the reach of even our most powerful telescopes, it will be gone permanently, continuing to drift through the emptiness between stars for what will likely be billions more years, carrying with it chemical secrets from whatever distant, long-dead star system it originally formed around. Some researchers have even pointed out that, statistically, the odds of any single interstellar object happening to pass close enough to our Sun for detailed study, rather than sailing through the far larger, emptier reaches of space between stars, are genuinely tiny, which makes the fact that we've now caught 3 of them within less than a decade feel less like luck and more like a sign of just how much survey technology has improved in a very short span of time. That's really the significance of everything Hubble, Webb, SphereX, and the rest of that improvised international fleet of telescopes and spacecraft managed to capture over these past several months. It isn't just a pretty picture of a glowing space object. It's a direct chemical sample, gathered from millions of miles away without ever touching the thing itself, of material that predates our own Sun, material that formed under completely different conditions, somewhere else entirely in the galaxy, briefly passing close enough for us to actually study it before vanishing again for good. It's genuinely remarkable that we live in an era where humanity's response to a discovery like this is to mobilize over a dozen separate space telescopes and planetary missions, from Mars orbiters to a Jupiter-bound spacecraft to a solar probe, all repurposed on short notice to study a single ancient wanderer passing through our neighborhood just once. Only 3 of these interstellar objects have ever been confirmed crossing our solar system. Oumuamua in 2017, Borisov in 2019, and now 3I Atlas. And each one has taught astronomers something new about how common or how rare objects like this actually are drifting through the wider galaxy, and about how differently material can form and evolve around other, much older stars compared to our own comparatively young solar system. Whatever comes next, whichever telescope eventually spots interstellar visitor number 4, the tools, techniques, and international coordination refined chasing down 3I Atlas will almost certainly make that next discovery even faster and even more detailed than this one already was. It's worth taking a moment to understand exactly how a survey telescope in Chile manages to spot something like this in the first place, because the discovery itself is almost as interesting as the object it found. The ATLAS survey, whose full name is the Asteroid Terrestrial Impact Last Alert System, is a network of telescopes built with a very specific job, scanning the entire night sky repeatedly, night after night, looking for anything that moves against the fixed background of stars. Most of what it catches turns out to be perfectly ordinary asteroids and comets that belong to our own solar system, tracked for years by astronomers who already know roughly where to look for them. What made the object spotted on July 1st, 2025, different was its velocity and the shape of its path. Software that automatically calculates an object's orbit from just a handful of observations flagged this one almost immediately as moving too fast, and on too open a trajectory to be gravitationally bound to our Sun at all. Within days, follow-up observations from telescopes around the world had confirmed it, and 3Y Atlas earned its official designation, with the number 3 marking it as only the 3rd such interstellar object ever confirmed, and Atlas crediting the survey that first caught it. That naming convention itself tells you something about how rare these discoveries still are. Oumuamua, spotted in October 2017 by a different Hawaii-based survey telescope called Pan-STARRS, became interstellar object number 1, and its name, drawn from Hawaiian, roughly translates to scout or messenger reaching out from the distant past. A fitting description for an object that turned out to be wildly elongated, cigar or pancake-shaped depending on which model you favor, and that showed a small, unexplained acceleration of its own that briefly fueled speculation, much like 3I Atlas would later, about whether it might be something other than a natural object. That early Oumuamua acceleration mystery, incidentally, was eventually best explained by many researchers as likely caused by outgassing hydrogen too faint for telescopes of that era to directly detect, a mundane resolution that took years of careful follow-up analysis to settle. Object number 2, Borisov, discovered in August 2019 by an amateur astronomer named Gennady Borisov using a telescope he built himself in Crimea, behaved much more like a textbook comet from the start, complete with a visible tail and a coma, giving astronomers much greater confidence early on that interstellar comets, not just interstellar asteroids, were genuinely out there drifting between star systems. 3I's Atlas, arriving 6 years later, is now giving researchers by far their richest dataset of the three, both because of its size and activity level, and because of just how much more advanced our telescope technology had become in the years since Borisov first crossed our path. There's also a broader scientific question hiding underneath all three of these discoveries that's worth sitting with for a moment, because it's bigger than any single comet. Every time astronomers confirm another interstellar visitor, it sharpens their estimates of just how many similar objects might be silently passing through or near our solar system at any given time without ever being detected at all. Current models built from these three confirmed detections suggest interstellar objects of this kind might be far more common throughout the galaxy than anyone assumed before Oumuamua's discovery in 2017, potentially numbering in the trillions across the Milky Way alone, most of them simply too small, too faint, or too far from Earth for even our best current survey telescopes to ever notice. Under that framework, 3I Atlas isn't a freak, one-in-a-lifetime event so much as a rare, lucky, close enough encounter with something that's actually happening constantly, all across the galaxy, almost entirely invisible to us. Upcoming observatories specifically designed for wide, deep sky surveys, like the Vera C. Rubin Observatory in Chile, which only recently began full science operations, are expected to make discoveries like this dramatically more frequent in the years ahead, potentially catching multiple new interstellar objects every single year rather than once every few years, giving astronomers a genuinely continuous stream of fresh material from other star systems to study rather than these rare, precious, one-off encounters. There's also something worth appreciating about just how much technology had to come together at exactly the right moment to make this level of study even possible. Oumuamua, back in 2017, was discovered and gone within weeks, moving so fast and so faintly that astronomers barely had time to point a handful of telescopes at it before it slipped out of range entirely, leaving behind more open questions than answers. Borisov, in 2019, gave researchers a somewhat longer window and clearly showed classic comet behavior, an active tail and outgassing, which helped settle some of the uncertainty left over from Oumuamua. But 3I Atlas arrived at a moment when an entirely new generation of infrared observatories, Webb chief among them, had only recently come online, giving astronomers tools capable of reading a comet's precise chemical composition from hundreds of millions of miles away in a way that simply wasn't possible during either of the previous two interstellar encounters. That's part of why the data gathered this time feels like such a genuine leap forward. It's not just a third data point confirming interstellar objects exist. It's the first time humanity has actually been able to read one's ingredient list in real detail. None of that means every question about 3I Atlas has been settled. Its unusually high carbon dioxide content compared to typical solar system comets is still being actively studied, and researchers are continuing to model exactly what that chemical ratio tells us about the specific conditions and the specific type of star it most likely formed around. Its slightly unusual acceleration profile is still being refined, using the newest tracking data as the object continues its outbound journey. Science of this kind rarely wraps up into one single tidy headline the moment the telescope data comes back. It usually opens up several new, more specific questions, each one requiring its own follow-up study, its own peer review process, and its own careful cross-checking against the handful of other interstellar objects we've been lucky enough to observe so far. That ongoing, methodical, sometimes genuinely uncertain process is exactly what real astronomy looks like. A meaningful contrast to the instant, dramatic certainty that headlines chasing alien spacecraft theories tend to promise and rarely deliver. For now, the clearest, most responsible summary of everything Hubble, Webb, and the rest of that global observing effort actually found is this. 3I's Atlas is a genuine, confirmed interstellar comet, likely older than our own sun, made of ice and dust that formed somewhere else in the galaxy entirely, passing through our solar system exactly once before heading back out into the dark for good. It's rich in carbon dioxide, beyond anything typically seen in our own solar system's comets, actively venting water, methane, and other gases as sunlight warmed its ancient surface, and its solid core measures somewhere around 1.5 miles across, based on the best available post-perihelion measurements. That is, on its own, a genuinely remarkable scientific story, a direct physical sample of another part of the galaxy passing close enough for humanity's best instruments to actually examine it. No invented alien mothership required to make it worth paying attention to. Let me know in the comments what you find more fascinating. The idea that this comet might be older than our own sun, or the ongoing debate around Avi Loeb's more speculative claims. Hit like, subscribe for more deep dives into the latest discoveries from space, and I'll see you in the next one.